Rubix Talent Kids.
Hi friends, my name is Nidhish. Today I am going to be explaining you matrices. Now let's learn about matrices. So now the first topic in this is what is a matrix. So matrix is the singular form of matrices. So what is a matrix? The complex arrangement of things in the form of a rectangular shape. So the definition of matrix is the complex arrangement of things which are in the form of a rectangular shape. So for example, let's take something which is like A, B, C and D. This is a matrix. So here we have written as rectangle, and you might be wondering why here it is in the form of a square, because you all must have known that squares are also a special type of rectangles. So again, now let's take one more example like A, B, C, D, E, F. This is also a matrix. So instead of alphabets here, we can also take simple equations like x minus 1, here y plus 2, x y z 3 x. So like that we can take equations, numbers, variables, etc. Guys, now let's learn about the order of a matrix. Now let's take a matrix of like A, B, C, D, E, F. To find the order of this matrix, all we have to do is count the number of rows and columns. Here we have 2 rows and 3 columns. So here we represent the rows as M and the columns as N. So this matrix equals to M into N. So here M equals to the number of rows, so which equals to A, and number of columns equals to 3. So now this matrix order is 2 into 3. So similarly let's find the order for some more matrices. So now let's find the order for these two matrices. Now let's take this one. So in this we have one row. So we write 1 into and 3 columns. So 3. Here we have 3 rows and 2 columns. So it's always 3 into 2. So now let's learn about the principal diagonal. So what is this principal diagonal? So let's take a matrix of like A, B, C, D, E, F, G, H, I. So this is a matrix. Now let's write its order 3 into 3. So what is the principal diagonal? So the principal diagonal. Now we take this, the set of elements from the top left corner to the bottom right corner. So which is these 3 elements. Principal diagonal equals to A, comma E, comma I. So this is the principal diagonal. Similarly, now let's by the way, the principal diagonal cannot occur from the top right corner to the bottom left corner. So this is wrong. Principal diagonal occurs only in square matrices. So square matrices mean the order, so the number of rows equals the number of columns. Those kind of matrices are called square matrices. So now let's find something like A, B, C, D. So principal diagonal equals to A and D. So similarly, now let's learn about the trace of a matrix. So now let's take a square matrix. It's A, B, C, D, E, F, G, H, I, K, M, N, O, P. So this is the square matrix. So here, now let's see. Now first, to find the trace of a matrix, we should find the principal diagonal. So the principal diagonal is this. So principal diagonal equals to A, comma F, comma K, comma L. So to find the trace of a matrix, we have to find the principal diagonal. Then we have to add all the elements in the principal diagonal. So trace equal to A plus F plus K plus L. So this is the trace of a matrix. Types of matrix. So now we learn about null matrix. So what is a null matrix? So let's take matrix A equals to 0, 0, 0, 0, 0, 0. Its order is 2 into 3. So this is a null matrix because all the elements in the matrix are 0. So a null matrix means all elements in the matrix should equal to 0. Those kind of matrices are called null matrices. So now let's learn about row matrices. So now let's take A equals to 1, 2, 3, 4, 5. So its order is 1 into 5. So a row matrix is formed when the matrix consists of only one row. So in the similar way, let's take column. We also have column matrix. So what is a column matrix? As like row matrix, the matrices consisting of one row, one column are called column matrices. So this is a column matrix. Diagonal. So now let's learn about diagonal matrix. What is a diagonal matrix? So now let's take matrix A equals to -5, 0, 0, 0, 0, -7, 0, 0, 0, 9, 0, 6, 0, 0, 0, 0, 8. So its order is 4 into 4. So and its principal diagonal equals to -5, -7, -6, 8. So its principal diagonal consists of -5, -7, 6 and 8. You must have noticed that the elements except the principal diagonal are zeros. So we can write the definition of diagonal matrix as all the elements except the principal diagonal should be 0. So now let's learn about unit matrix. So what is a unit matrix? So now let's take matrix A as 1 0 0 1. No, okay. So it's this matrix order is 2 into 2 and its principal diagonal consists of only 1 and the remaining all elements are 0. So this matrix is called a unit matrix. So the principal diagonal consists of only 1 and the remaining all elements are 0. So this matrix is called a unit matrix. So now let's learn about the equality of matrices. So now let's take matrix A as A, B, C, D, E, F, G, H and B as -6, -7, 3, 5, -9, 8, 1, 4. So these are two matrices with the same order. So this first matrix's order is 2 into 4 and the same matrix B order is also 2 into 4. So both matrices have the same order. So they might ask you to equate both of these matrices A into B. So here A equals B. So here the first element of matrix A equals to the first element of matrix B. So here A equals to -6, B equals to -7, C equals to 3, D equals to 5 and so on. So this is the equality of matrices. Now let's learn about the addition of matrices. So here addition and subtraction both are very easy. So learn about addition first. So let's take matrix A equals to 1, 2, 3 and let's take matrix B as -6, -7, -9. So now they might have given A plus B equals to so here A plus B equals to, so first element plus first element and second element plus second element, third element and third element. So now this equals to -5, here also -5 and this also equals to, this equals to -6. So by the way, you can only add the matrices which have the same order, which means that they must have the same number of rows and columns. So guys, in the same way we also do the subtraction of matrices. So instead of here plus, they give it as minus, here also minus. So here we get it as like minus of -6 and here minus of -7, minus of -9. Then the answer would be 7, 9, 12. So this is the process how we can subtract these matrices. So now let's learn about the multiplication of matrices. Now let's learn about the multiplication of matrices. Let's take two matrices A and B. So let's take matrix A, take it as 1, 2, 3, 5, and this one as 6, 7, 4 and 8. So we have to, so we write A into B. So A into B equals, so multiplication of matrices is kinda hard, so you have to practice it more to do it perfectly. Here, now we have to take the first row of matrix A and the first column of matrix B. First row of matrix A and first column of matrix B. So we multiply this first element with this one. So we write it as 1 into 6. Now this and this. So we have to add this both. So now this equals to 2 into 4. So now we have to take this first row and multiply it with the second column of matrix B. So now this equals to 1 into 7 plus 2 into 8. Similarly, we do it the same process with the second row. 3 into 6 plus 5 into 4 and 3 into 7 plus 5 into 8. So the next step is to simplify this. So it equals to 6 plus 8, 7 plus 16, 18 plus 20, 21 plus 40. So add these all values: 14, 23, 38 and 61. This is the answer of A into B. So by the way, can you tell if A into B equals to B into A? Well, you might be wondering if it's possible, but it's not. So A into B doesn't equal to B into A. Now let's see why. So now let's take some different kind of matrices. So let's see matrix A. So matrix A equals to 3, 4, 5, 6, 7, 8. So take its order: 2 into 3, and this one would be written like so. Now let's take this one as 1, 2 and 3. So its order is 3 into 1. So you can multiply these matrices, because before we learned how to multiply the matrices with the same order. Now let's learn how to multiply the matrices with the different order. So here m into n and here m into n. So here the number of columns of the first matrix should equal to the number of rows of the second matrix. So here we have 3 columns and here we have 3 rows. So the resultant matrix, so the final answer which we would get would result as 2 into 1. So we would get a matrix with some unknown values here, x and y. So we will solve this and see what is the answer. So now let's take A into B equals to, so the first row into the first column and the second row into the second column. So it becomes, so 3 into 1 plus 4 into 2 plus 3 into 5 and 6 into 1 plus 2 into 7 plus 8 into 3. So simplify this. 3 plus 8 plus 15 and 6 plus 14 plus 24. So now this equals to 26 and 44. So this is the answer for A into B. So now let's see what is B into A. By the way, we cannot multiply B with A, but we can multiply A with B. Now let's see why. We cannot multiply B with A, but we can multiply A with B. So when we multiply A with matrix B, so here we have the same number of rows of A and the same number of columns of B. But now let's take this. If we multiply it in the reverse order, then the order would become 3 into 1 and 2 into 3. These two values are not equal, so we cannot multiply them. So guys, now let's learn about the transpose of matrix. So what is the transpose of a matrix? Let's take matrix A equals to 1, 2, 3 and 4. So here we have 2 rows and 2 columns. The transpose of a matrix. So the transpose is written as A to the power of T. So this is the symbol of transpose. So now this equals to 1. Now the first row becomes the first column, so 2 comes here, and the second row becomes the second column, so 3 and 4. So this is the transpose of matrix A. Similarly, let's do it for something like 1, 2, 3, 4, 5, 6, 7 and 8. So matrix B transpose equals to, the first row becomes the first column, so 1, 2, 3 and 4. Then the second row becomes the second column. So this is the answer of B transpose. So guys, now let's learn about the symmetric matrix. So now let's take a matrix A as 1, 2, 3, 2, 1, 2, 6, 5, 3, 5, 9. Now let's find the transpose of this matrix. So A transpose equals to 1, 2, 3, 2, 6, 5, 3, 5, 9. So here A equals to A transpose. So a symmetrical matrix is formed when the matrix A equals to its transpose. So now let's learn about skew symmetrical matrix. So guys, now let's take this. We have taken skew symmetrical matrix. So we have taken this matrix 1, minus 2, 3, 2, 6, minus 5, minus 3, 5 and 9. So A transpose equals to 1, 2, minus 3, minus 2, 6, 5, 3, minus 5 and 9. Here A doesn't equal to its transpose, but we call it a skew symmetrical matrix because A transpose equals to minus A. When you multiply this with a minus sign, so the answer would be this. So you get the answer this. So this is a skew symmetrical matrix. So let's see some simpler ones. So let's take it as 0, 5, minus 5 and 0. A equals to this. So A transpose equals to 0, minus 5, 5 and 0. So this is a skew symmetrical matrix. Thank you friends, that's today's videos. If you like my videos, please like, share and subscribe.